Swayam Prabha. Digital India. Educated India.
Now, let us just look at a simple example. We are almost on the equator of the earth, right. So, the earth is rotating, right. Let us assume that this is the polar direction, okay. It is rotating, the earth is rotating, I am standing on this, right. Will I have an acceleration? Let us look at it. So, this is the center and it is rotating, right, with an angular velocity. Is it angular velocity or angular acceleration? Almost angular velocity, because it is a constant velocity angular rotation that it is having, okay, and it is not very difficult for me to find out. It rotates about 360 degrees in a matter of only 24 hours, right. So, I can always find out omega. Now, the question I have here is this man who is standing, I am standing on the equator, am I accelerating? Let us say the fixed frame of reference is with respect to the center. The answer is yes, because as the earth is rotating, I am also going around it, alright. And what would be the acceleration here? If this is given by, this is B, this is A, I am going to use the same notation so that it is easy. So, that I have R B with respect to A, right. A is also the origin, so it makes it easy, R A equals 0, okay. And therefore, if I have to find out R dot of B, it is nothing but R dot of B with respect to A, okay. R double dot of B with respect to A is what I am interested in, and that will be given by, as we have already derived, alpha cross R B with respect to A, which is the tangential component of acceleration, plus the radial component, inward radial component of acceleration is given by this, right. Omega is known, omega is known, R of B with respect to A is also known here. So, I can find out, okay, and therefore, this is not 0. Whereas this is 0. So, a man standing on the equator will see an angular acceleration inward, okay, when he moves from here to here, right, and that is given by this. Okay. The rest of it is not very difficult for you to find out what will be the, and the direction is very simple. The direction is, it is directed along, the acceleration is directed along the center of the earth or towards the axis. Is this clear? Okay, let us see if we can answer this question. What is the man doing? The man is just standing still, so no problem. What if the man is moving on the equator? Now, you have two things, the earth itself is moving and there is this man who is also moving, okay. Probably he may be accelerating along, let us say, the equatorial line. Can I find out what is the actual acceleration velocity of that particular person? Okay. Let us do that exercise and see whether we can do that. What is the difference right now compared to what we did earlier? In the earlier exercise, this point B and point A had one particular relationship, and what was that? A, what was the particular relationship that we knew? Let us make it a little more complicated, so that you can think a little differently. Let us say he fitted himself, like our Shastra, he fitted himself with a particular rocket booster, and is going like this. So, he just shot up like a bird, and he is going like this with an acceleration. Can I find out the actual acceleration of this particular person? Let us try to answer that question. Okay. One other way of looking at it is, supposing I have a body, okay, and let us say there is a small marble on this body which is moving independent of, or let us say there is an insect. There is an insect that is moving around with a velocity or acceleration. Now, remember, this body also is moving and accelerating, okay. And can I find out with respect to fixed frame of reference what would be the acceleration of this particular insect? Why am I interested in acceleration of that particular insect or velocity of that insect with respect to the fixed frame? What is the reason? Why can't I just live with whatever acceleration that I am seeing when I am standing on this? Because the acceleration that I am seeing when I am standing on this rigid body is a relative acceleration, whereas the Newton's law can be applied only if I have been able to fix a particular frame, a non accelerating frame. In this particular case, those are these capital X capital Y frame. Okay. So, if I can define with respect to this frame, then whatever acceleration that I find out can be used for F equals ma equation. Okay. So, the entire exercise is to make sure that I am able to use the equations of motion. That is the idea. One thing that I already know is, if I have a point, okay, and relative to, let us say this is A, relative to this point A, we already found out what would be the relationship of any other particle that is fixed to this rigid body with respect to A. Okay. Now, what we want to do is, we want to find out what would be the acceleration of this guy, okay, actual acceleration or acceleration with respect to fixed frame rather than a frame attached to this, which means first thing I have to do is I have to attach a frame with this body. Okay. So, let us attach a frame. Shall we attach a frame like this? Okay. What about this frame? If this rigid body is rotating, this frame also will be rotating. That understanding should be clear. Okay. So, let me call this as small x, small y, okay, and this can be taken to be r, the position of the insect with respect to this frame that is attached to this rigid body. Okay. If this insect were not moving, it is easy for me to find out what it is, right, because this distance is maintained. Okay. So, the only difference that I see is that this distance is not maintained as far as the insect is concerned. I have to consider that in my equations. Okay. So, let us proceed to do that exercise. Let us take this as R A. Okay. Let us say this is shall we call this as B? Let us just call for now this particular insect to be positioned at B, okay, and this B may be moving with respect to A, alright. So, let us say this is R and this is RA, okay, and this is RB, okay. Like what we have done, how do I find out RB? RB is given by RA, which is the location of the point at which we have fixed the axis, plus R. And what is R? R tells me the location of this particular insect, okay. Now I have to find out the velocity, and velocity is not very difficult. If I have to find out the velocity of this insect with respect to fixed frame, what would that be? It would be R dot A, okay, plus R dot, okay. So, this is very simple, this is nothing but VA, because I have already defined RA with respect to fixed axis, there is no problem in defining VA. Now, we have an R dot, remember this has a magnitude and a direction, okay. So, I have VA plus, I am going to now write this as R dot magnitude, or rather R magnitude times the direction, okay, the entire thing dotted. It makes it easy for us to now understand, alright, which is nothing but VA, and if I differentiate by parts, it is the derivative of this, okay. So, let me just call that as R dot times R cap plus magnitude of R times okay. Is it confusing? It is fine. Let me just write it a little differently, plus R magnitude times R cap dot. What is this? You are taking, for example, if I am doing this, it is nothing but, what is this? This is I j k taken here, and this is nothing but the magnitude of R dot, okay. So, it is x dot I plus y dot j plus z dot k. Do you understand this? This is what it means, okay. So, if I write this as this, let me call this as V relative. Why? Because if I am standing on this and having this fixed frame of reference on the rigid body, and I am seeing the insect moving, that will be the derivative of x, y and z, and therefore I am going to call that as V relative. So, what I know now is this is V relative, correct, and there is one more term here, which is the magnitude of R times the derivative of the direction R cap. How do I find out the derivative of the direction? If there is a rotation occurring, so I know that this is rotating, right. If it is rotating, how do I find out this? It is nothing but omega cross R cap, okay. So, using that I will get VB equals VA plus V relative plus omega cross R. That is it. As you can see, if I do not have this, it is nothing but Vb equals Va plus omega cross r, which is something that we already knew for a rigid body. What is added to that is V relative. Okay. Now I seek to find out accelerations, acceleration of B, and I want to relate through acceleration of A, right. Acceleration of B I want to know given acceleration of A, okay, and the rigid body movement. Okay. So, how do I get it? Let me just translate this over there because it is easier. What I have here is V dot B equals V dot A plus V dot relative plus omega cross r dot, simple, alright. Now instead of writing V dot relative, I am now going to use what we have already written here, which is the r dot times r cap, okay. So it is Va plus r dot cap r dot times r cap plus omega dot cross r plus omega cross r dot. Is this okay? Remember V relative, V dot relative is a vector again, and if I take a derivative of that, I will have to take the derivative of the magnitude as well as the direction, and that is an important thing that we have to do. Oh, this whole thing dot. V dot relative, V dot B equals V dot A, oh here V dot A. So let us just rewrite V dot B equals V dot A plus this V dot relative, again I have to now look at the magnitude and the direction, right. So let me write it as either this way or this way. I have V magnitude, V dot magnitude, let me write it like this, V dot magnitude times, let us write V relative magnitude times V direction, okay. This whole thing taken derivative of, okay, plus omega dot is nothing but alpha, alpha cross r, that does not change. Again I have omega cross r dot, right. Now this is acceleration of B, this is acceleration of A, plus this I have to now resolve. How do I do that? This will give me two terms. One term is related to derivative of V relative, right. So I will get A relative, which is nothing but a derivative of V relative magnitude times the direction, which is A relative. I am going to write it as A relative plus V relative magnitude, right, times, which will give me what? Directly I can write this to be omega cross is that okay, plus alpha cross r plus what is this? What is r dot? R dot again I can take from here, I have already written r dot here, r dot happens to be V relative plus this, right. So I have omega across, I know that this is the thing that is related to r dot. So, I will write it as V relative plus omega cross r. Is this clear? This is clear because if you look at this particular expression r dot, this r dot manifests as V relative plus omega cross r. Okay. And therefore, here that is how it manifests. Okay. Now, we just have to group them together. What do we get? It is nothing but A plus, let me write this, plus, notice here I have two terms, omega cross r, omega cross V relative. So, let me write omega cross r plus, I have this term which is A relative, plus what else is left out? Omega cross V relative added together is 2 times omega cross V relative. What was this? What is this that you know of? AB equals AA plus alpha cross r plus omega cross r. It is the one that we found out for a rigid body. If there is an insect that is moving with an acceleration or whatever, it will be the relative acceleration with respect to the rigid body on which I am standing stationary and then looking at it, plus one more term. Okay. And this one more term is what is counterintuitive. One would think, okay, if I have a point over here and this is a fixed point with respect to the point that I am looking at as the pivot, and when it is rotating, this acceleration is given by AA plus alpha cross r plus omega cross r, and therefore, if I have an insect that is moving with an acceleration, I should expect an additional A relative. But what is counterintuitive is there is an additional term that comes in, which is omega cross V relative, and this counterintuitive acceleration is often called as Coriolis acceleration. Is this clear? Okay. Otherwise, it is a very simple idea that I can understand, but upon doing this derivation we find that there is an additional acceleration. Okay. We already found out what would be the direction of this, what would be the direction of this. The direction of A relative is not very difficult to understand, it is along the direction of r, right. And how about this? It is perpendicular to the direction of omega, which is nothing but the perpendicular to the board, and it is also perpendicular to V relative. Understood? So, if I take a perpendicular direction with respect to those two, okay, so this and this is the direction in which I will expect Coriolis acceleration to occur. Now, a simple example, let us say I have on top of a tower, imagine I am the tower, on top of it there is a rotating restaurant, alright. So, this is a rotating restaurant, this is the center of it, there is a person that moves with a constant velocity. what will happen is there will be an acceleration that he will experience, which will be perpendicular to his velocity that he sees and perpendicular to the direction of the rotation. So, perpendicular to this, and let us say he is moving towards the center, perpendicular to this and perpendicular to this is a direction like this. So, he will see himself moving, being pushed like this, okay, and that is what is called Coriolis force. Okay. So, when you are in the relative realm, you will seemingly see that acceleration. So, when you are outside with the fixed frame of reference, this seems an acceleration that does not give any sense of feeling that you see when you are inside the restaurant.